Good morning and welcome to Heron Innovators virtual booth here for WEFTech Connect 2020. My name is Andrea Hofstetter. I am here in California representing Heron Innovators, home of the suspended air flotation. I am here today with the president and founder of Heron Innovators, John Barsotti.
Good morning. Still morning, right?
Yeah. Still morning. It's Friday, so at this point, as long as we're here, we're live, we're doing the best we can.
We are.
We've made it this far. I appreciate anybody who's joining us again. If you've seen any of our presentations this week, this is again very new and different for us. Like I keep saying all week. We would much rather be meeting you in person in our booth. We've been doing this in Chicago and New Orleans for several years now, and this is definitely different and not as fun or as enjoyable.
I would say that's pretty good, right?
Yeah.
To that end, Andrea, we want to always remind them that our audience that we are not comfortable doing this, right?
Oh, no.
Yeah,
of
so
course
we're
not.
very used to having a face in front of us and able to talk to them, answer the questions directly. And so we got these canned presentations that we're trying to remember while the camera's on us, and so we're gonna miss something. So we have that chat feature, right? And so let's make
Any
sure.
comments or questions you might have, please use that chat feature because we'll be watching it during the entire presentation, and if we need to speak to you, or we would love to feel like this is more of a conversation than just a presentation. So please don't be shy. Go ahead and talk to us. We are both Italian, so we're very social with our hands and with our voices. So at any time, reach out to us and talk. And with that, I'll go ahead and let you go ahead and introduce yourself, and we can go ahead and get started.
As Andrew said, I'm John Barsotti. I'm the president and founder of Heron Innovators. We started this company in 1997 in someone's backyard. We've got more than 100, we've got hundreds of installations at this point, and we are actually kind of growing. We're kind of having trouble, right? We're bursting at the seams. We're growing, and we're trying to keep that same level of customer service we've been known for all these years. I come out of industry, so I really do try to be very sensitive to that. So we're trying to grow the company with the model that we maintain as customer service. To that end, we're going to a bigger building next year, so we can get more people, more space, more stuff on the shelf, all to serve our customers. So this presentation is about being unbelievable, and a little markety, that kind of thing, and I wish I could do it better, but Jeff Knollenberg, who's normally here, who hasn't actually been able to come here. The first level of difficulties, he ended up being quarantined in Kentucky, and for the first part of the week we were doing it with Jeff, right here, virtually with Jeff, and now Jeff has actually had to go off this last day, and so actually yesterday and today, and so now it's going to be all me, and unfortunately for you folks, I'm not that exciting to listen to, but I'm going to do my best.
Yeah, Jeff got out of that quarantine, and he got out of his house as fast as he could to go meet with people face to face, because again, that's what we like to do.
Right. So this presentation is probably, I've been told, we've covered how SAF works in 5 of 10 presentations, 9 of 10 presentations, right? 2 a day, I gotta remember, 9 of 10 presentations. And so this one, I'm just gonna go through a little bit about what makes us great, and like that rise rate thing to be like 3 slides. And then I'm just gonna go through examples of the kinds of numbers we get and what traditionally is seen in these applications before we got in those spots. So I'm going to jump right to this video. Come on, I'm trying to wake up my mouse here. Why isn't my mouse waking up?
It's Friday. We're all a little sleepy at this point, right?
Actually, I'm having trouble here, guys. I'm not getting this mouse. The mouse isn't there. There's the video.
There's the video.
But the mouse isn't working. Okay. So the mouse is not.
What's exciting now about wastewater in the 21st century is that we're now considering it a resource. In the 20th century, it was considered a waste, and we developed treatment processes to incrementally deal with various constituents. But in the 21st century, it's become a resource. Wastewater is a renewable, recoverable source of potable water, energy, and resources. That opens up whole new vistas in our thinking about how to manage wastewater. Charge bubble flotation is equivalent to Heron Innovators' suspended air flotation unit. The best way to explain it is from a picture from one of my textbooks. And I'm pleased to say that the 5th edition is now out. And what's exciting about this is I've been able to include alternative kinds of treatment processes, including the charge bubble flotation in the unit. And I think what Heron Innovators has done is innovate around the process. One of the exciting possibilities is to think about alternative treatment process flow diagrams in which charge bubble flotation is used to precondition the wastewater before you do other types of treatment. The concept is that instead of treating wastewater the way it comes, we would modify the characteristics of the wastewater to enhance subsequent treatment. We have conducted a couple of experiments. We take raw effluent and we flocculate it and condition it. Simultaneously, we generate microbubbles to which we've added a polymer. We then mix the microbubbles that are covered with this polymer with the flocculated wastewater. At that point, the bubbles rise to the surface carrying suspended material that they've attached to. The thickened material is removed and the underflow is the clear liquid that is then subject to additional treatment. Well, this is very promising because it allows us to work over a wide range of flow rates and concentrations and achieve a uniform effluent. Now, the interesting thing with CBF is, based on our experiments, is that you also remove organic matter. Now, as you continue to remove both suspended solids and organic matter, you get a waste now that is very low in organic matter, and you can think about different types of treatment processes. In addition, you can take the material that you've removed and use it in an anaerobic digester to produce energy. So there are a number of possibilities here, but I think that it opens up new avenues to think about secondary treatment.
Hi. So Dr. Chabanaglis is a big proponent of enhanced primary clarification. I mean, imagine you saw that he couldn't resist the opportunity to try to sell his new Metcalf and any manual on our deal. But for that we are in the manual, so that all worked out well for both of us. So earlier talk was about water reclamation, and that was a big deal, right? It's like we can take primary water, we can get the materials out of there, we can get the energy out of that solids, and so on and so forth. So he's a huge proponent of ours, and we've worked well with him for many years. We appreciate him talking on our behalf. So this next slide now is just something to show you the rise rates, the comparative rise rates of DAF. And so you can see in 30 seconds we're done. Those two take 240 to 180 seconds, and the subnatant, or the water underneath, never quite looks as good as that SAF does even right now. And then here's a little jar test to kind of demonstrate that mesoneum rise rate. I think the other thing you might look at here is how the particles puff up when this happens, and that's a coagulation feature I've talked about, video. It's probably why we save so much on chemistry, both on the industrial and the municipal markets. And it's significant. It's 30, 50, 70% on chemistry, and you'll see that if you look carefully into the glass, you'll see these particles go from the size they are now, and they actually puff up. And I'm going to go ahead and play that video right now if I can. There you go. You see that? Oh, they can't hear me right now. Yeah, okay, so they can see that rise rate and how big those particles puffed up and how stable that float is. that's a testament to how well our air is used and how much air, because those surface tension advantages I've talked to previously, how much air gets on the particle and how fast that goes up. So I'm going to move on. I kind of set this up for a host of eventualities, but I'm going to kind of move on here. Well, let's talk about this really quick. This is our flock mixer, and there's a video on that thing. Let's get that thing on just so you get kind of a nice rendition of it. So this is on the outside of our float cells, and this is incorporated. The technology works best in our float cell, but we can use it in a lot of system retrofits for existing DAFs. And so what we do is, unlike a DAF where you need to be able to mix, the air is mixed easily because there's so much water carrying it. In our case, we're talking about like the equivalent recycle, if you call it recycle, like 1%. And I need to mix it rapidly, and that's why we need this mixture. And it's the same thing we incorporate into a DAF retrofit or a DAF conversion to SAF. We get a lot of the same advantages, maybe not quite as good as we can get on our own float cells, but it's pretty impressive. It's like some multiple of original design, usually 4 or 5, as much as 10 and sometimes. This is an actual flock mixture that was being manufactured for one of our clients. And this is an actual installation where you see the flock mixture on the top left. Let's see if I can reach that thing on the top left. Right here, can you see that? And then on the right is our SAF generator, and that's our secret sauce. And this is now and that's actually the flock tube on an installation, actually in Southwest City. So this has got a good story, and I'm curious if I want to. Again, I'm having trouble with the computer here, but right here you can see that there's a control cabinet for the F200 generator that was utilizing this retrofit. On the top up there is the flock mixture. You can kind of see it with a motor hanging off to the right side of it. And so the water comes out of that flock tube, enters through the flock mixture, what we call the clear mixer, and it goes into the float cell. And all the froth is fed. You can actually see the line if you look carefully, but it's all fed on the inlet of that mixer before it goes in, and then the froth and conditioned water continues to be mixed going through the tube all the way to the inlet of the DAF. And so this DAF here was kind of challenged, right? It had, they not only had a mixed liquor that they were feeding from an MBBR, but they were trying from a downstream SBR, they were trying to feed the settled solids or waste activated sludge from that SBR back to this fairly large DAF actually. And the DAF is actually spec'd for 2,500 gallons a minute. They were barely getting 1,250 gallons a minute, and just about any time they introduced any of that downstream waste activated sludge, they lost the process. And for years they were trying to manage that and had convinced themselves they had to go buy a new piece of equipment. Well, they met us. Simmons met us. You saw that jar test actually I showed you earlier came from Simmons, and they put this in. And Andy there, who's in the background in the black shirt, will tell you that before we got up the stairs, this was working, and they're doubling the solids loading today, and they're nowhere near capacity. They're running easily. I don't think they're pushing the system very much as far as solids flux, and they're running, about 12 to 15 pounds per hour per square foot, which is double what they were able to get, more than double actually. It's about 3 times what they were able to get before, and they still have all kinds of capacity available. Next slide here kind of shows, you can see down here, there's a little video. I'm going to run this, but you can actually see the clarity of the water. This is down on the bottom right. I'm going to run this. But the clarity of the water, and that's actually a reading off the turbidimeter, showing a turbidity of 0.2, I believe. So let me get that going for you here. I am having trouble. There it is. All right. There. You can see the clarity of that water. It's very clear, and it's very low turbidity. And I don't know that they're always at 0.2, but they're always way down in turbidity, and they just got all kinds of capacity left in that operation today. I remember the vice president of engineering continuing, after we put our first installation in another plant, he kept coming back to us and saying, but you said you could do this on this other one, and almost like a dare, and they couldn't be happier today. So, all right, I need to get to the next slide, and I'm just going to go like this and like that. And that one we just saw, so we're going to move on. Okay. And this is actually, this is also an industrial setting. This is poultry, and this is large units. There's a good story to go with this. I mean, they're making great water. They have, the intent originally was to come into the primary unit, right? Go into one of our SAFs, then from that SAF go to a biological reactor, and then have the secondary SAF remove the biomass before it discharged the city. And we ended up, for months on startup, they never ran, they figured out they could meet their numbers by just going into the 1 million gallon or 1 day retention EQ tank. So they ran like that for 6 months or so, never turning on the aerators underneath because they weren't running the biological process. Well, what ended up happening is the bottom started filling up with solids. So in an interesting note, one day they turned the air on and threw a bunch of solids in solution that would have accumulated on the bottom. And at one point they were running that 140 square foot cell at 2,400 gallons a minute at 36 pounds per hour per square foot. 35, 36, I'm sorry, I keep, that number was in there somewhere. But it was an amazing performance, and the operator, and Andy, who's the chief operator out there, said, you know, we would go harder, but we can't, the pumps can't put out anymore, but I know this can do at least another 10-20%, because the water was crystal clear still. So we were, you know, easily over 2,800 gallons a minute, or 20 gallons a minute per square foot loading in that water. Then we do a lot in solid thickening, both industrial and municipal. So this is one of our installations that was dealing with an anaerobic sludge, anaerobic digested sludge. We were told that we were the best performing DAF in North America. We were, you know, we're in a world where they were all hoping for 70% removal. We averaged 98% removal consistently. And that 1 million gallon a day unit is 28 feet long with everything on it, right? All the day tanks and all the working tanks and all that is 28 feet long and 10 feet wide. Okay. And then another example of this, we have a trailer that we had down in up in Minnesota, and that trailer was treating, again, anaerobic sludge, and that's just recently. We were competing head-to-head with a competitor, a DAF competitor, and we were achieving all those same results I've been talking about earlier. So we went as high as 46 pounds per hour per square foot loading. We almost always above 99% removal at about half the chemistry of the competing technology. Most of those parameters, but you know, the loading rate was really a significant parameter that we really excelled on, with the fact that we were able to do it at a fraction of the polymer loading that they would have to do if they were going to use a DAF. All right, let's see. I got a few more slides here. Let's make our way. Here's another slide showing that same installation. Here's the solids, and this is actually a video. Let's go. What you can't see here is the flight is actually buried in those solids, and it's about an 8-inch deep flight. So when this comes on, it's gonna, and remember, we're still doing 98%, 99% removal, and we are also achieving 99%, 98, 99% removal in the water, and we're achieving anywhere between, we never went much below 30 or 29 pounds per hour per square foot, but we've achieved as high as 46 pounds per hour per square foot in this application. And I think you can see that in the solids coming off. And those solids were generally between 5 and 6%. I'll let that go ahead and go for a little bit. You know, just inches of solid slide. Here comes the blade. Here's the 8-inch blade that's buried, right? There you go. Okay, let's go on to the next slide. The next slide is another thing we do, another water we treat particularly well is water with algae in it. And we have examples where we've done it for primary water where they're actually using algae to aerate the stream to go into the secondary process. In those applications, we're seeing 400 to 600 parts per million algae, and we're treating it down to something less than 2 NTU. And what you're looking in front of you is a water reclamation application at a prison here in California, and they're selling it for irrigation to agricultural concerns around the plant. So, we're achieving 0.2 to 0.8 NTU from water that's coming in at 60 to 100 NTU. We're easily getting to 7 to 10% solids, which is unique compared, our competing approaches are looking at, 2% as being like a really good number. So the fact that we can get so high, that's a lot less water you got to haul off. And then it's such a robust solid that it dewaters well in downstream dewatering. And what this solid is doing is it's going into a lined baker box. It continues dewatering, then it gets disposed of as a solid meeting the paint filter test. So next is Greyton Community Services District. I'm going to move this over. It's going to be another video, and that video talks about one of our first Title 22 algae, in wastewater reclamation projects. I don't know if you need to know, but I'm going over there right now.
I serve the District of Greyton as their general manager. I'm a contract general manager. I've worked in the field 37 years. Greyton is a unique environment. It's got beautiful wildlife resources, and it had been run down by the previous management. The people of Greyton decided to take over and form their own special district and revitalize it. They inherited some problems, one of which is Greyton would not be allowed to continue to discharge into the Atascadero Creek. We actually conducted a pilot study here at Greyton, full scale, and we proved to the state that we could get the required removal of algae and bacteria from the water with a SAF to get turbidities down in the 10 range or lower. Pete Lescure and I were working with the district to try to find alternatives to going to this activated sludge or regional system.
With the lead designers on this Greyton wastewater project, I was convinced from the viewpoint of the principals that whereas a DAF, you have to backtrack, recycle 50% of what you're trying to produce, the SAF only has to use 2% of that flow. So that means a whole lot less pumping you're doing. That's a whole lot less material handling you're doing. Smaller pipes to deal with, etc.
The SAF unit takes water from our ponds and adds coagulant to it in this mixing tank and conveys it to the bottom of this SAF unit where a surfactant and air are entrained and cause the algae and bacteria to float to the surface. When they get to the surface, they're collected by this scraper and carried all the way to the end of the SAF unit where they are brought up on a beach. The water drains off and the solids fall into a bin. The bin then is dewatered by gravity and it is composted. People don't always want something new. Do we need to continue with things that were developed in 1911 that are shown to be less efficient than things that are now available in industry? I believe not. And we'd like to show them it's okay.
So, in this application, those solids, which are, municipal waste solids basically, are composted and then land applied. So it offers another option for how to kind of reintroduce these reintroduce these solids as a piece of sustainability. All right, so I got a couple more slides here. And these are a lot of sewer plants will end up, and other plants have to divert water in high water situations to some sort of equalization basin where the water actually gets dirtier, right? So you got primary solids in there, and then algae and silt kind of get suspended in the water, and then it needs to be treated, and the downstream process doesn't serve for that very well, right? It doesn't accept that algae very well. So we are asked to pre-treat before that water is reintroduced, and here's a video on that right now, a little short video. You know what? I think I just hit the wrong. Let me move to the next slide. That's not supposed to be what's up. I don't know how that got on there. Move. There we go. All right. This is the video here. Here you go. All right. Sorry, but I have a second one here that's almost as good. So let's go here and let's look at this. There we go. So this is primary wastewater that's been diverted into the EQ basin and then treated before it gets reintroduced into the plant. Okay, so that's my last slide. I think that's enough to demonstrate what we can do in really heavily, contaminated water and lightly contaminated water, different medias, algae, digester solids. We seem to be very good at solids removal in just about every application we come across where DAF previously had an application, or any kind of high rate clarifications needed. Okay, so we do have a question. I'm going to
Yes, thank you.
Andrea take it from here for a second.
So our question right now is, have you ever met a client that's actually dissuaded from buying SAF because it sounds too good to be true?
Yeah, so Andrew, that was the rule when I started this company, right? We would come in and just about any metric you could apply to DAF, we were saying we could do not just a little bit better. And so it was too good to be true. No one could believe it. Now with these hundreds of products in line and there's this pretty good install base, there's a lot of evidence of that. And it's getting to be less of a problem, but still, engineers are really slow to accept that kind of statement where are very skeptical because it does. If this is the first time you heard about SAF, it does sound too good to be true. And it is something that we strive to overcome often. So.
Yeah, I have to say that your results are unbelievable. If I hadn't seen them with my own two eyes, I would question some of the things that you're saying as well. But, there's always time to ask us questions and let us talk to you and show you how we can improve your results and make everything run a little bit smoother and more effectively. So.
Very good. Okay. Well,
all right, and with that,
this is the last show.
This is our last one, and so it's been a pleasure with all of you joining us. Again, you can always contact us at info@heroninnovators.com or check out our website at www.heroninnovators.com. We love to inform and get this information out there. The more people that know, the more waters we can treat. And so with that, have a wonderful Friday, the rest of your 2020. I hope you're healthy. I hope the lockdowns end pretty soon and that we can get back to life as normal, and we'll be meeting you in person next year I'm not sure if it's Chicago next year. I don't know what the plan is, but wherever WEF Tech is, you know we will be there. So until then, everybody, bye.
Bye now.